thank everyone again. Like Trevor said, we know your time is valuable, so hopefully you get something out of coming to these things. And I know we're kind of short on time for this session, so I've got a few extra slides in here that I'm going to probably blast through just to make sure we get to the meat of the presentation here. So really, what I'm intending to talk about is, what is fleet monitoring? What is device monitoring in general? What is different about it specifically with, internet connected devices, Internet of Things, that kind of thing. Look at some of the options that we reviewed to include in our Torizon product. And present a proof of concept implementation in Yocto that doesn't require Torizon. I've got an actual Yocto layer. I'm sure it doesn't follow all the best practices, but it is just a proof of concept, just to try to show some of the things we are talking about here. And then also talk about some of the way it's implemented in Torizon, just to give you a flavor of some of the kinds of decisions you'll need to make if you're looking at rolling out a system like this with your devices. Just briefly about me, you see all my contact information. I love, if you have any questions that don't get answered here, feel free to reach out. There's a lot of contact info on there. My current role, I am the solutions architect for the Torizon platform, which is a full end-to-end system, including the base operating system, as well as the container runtime, platform services, including over-the-air updates, and the device and fleet monitoring and that kind of thing. So that's my current role. And in case you're not familiar with Toradex, we make systems on modules. Here's some pictures of them. I like this slide because I always like to see pictures of hardware. We have 3 families, and they're all pin compatible within a family. So if you're not familiar with us and you need hardware, please check us out. So I'm sure we've all heard the term pets versus cattle. And if you haven't, it was originally coined by a guy named Randy Bias. There's a long blog post there about it, which is kind of interesting reading. It's originally from the enterprise computing space, so the original meaning of it doesn't necessarily apply directly to our homogeneous device fleets, but in IoT, you think about pets or your weekend projects. The Raspberry Pi I got sitting on my desk that is controlling a 3D printer that I log into manually and I keep updated. My home automation stuff with Home Assistant, that I carefully cultivate and manage one at a time. Versus, cattle is when you're, producing a medical device and you've got a fleet of, thousands or tens of thousands of devices out there. You certainly don't want to be logging into those individually to manage them over the product life cycle. And then, fleet monitoring adds on top of that, of course, structured access to the data typically for cattle devices. You could do something like this for your weekend projects and that kind of thing, but I doubt most people end up taking the time to do that. So real quickly, fleet monitoring, what is it? As I often do when I'm putting together these talks, first place I go is to Wikipedia. And everything on the Wikipedia page was about automotive fleet management for trucks and things like that. It really wasn't about device fleet monitoring when you're talking about internet connected devices. So that wasn't terribly helpful. But really, from my point of view, it's periodic monitoring, gathering of the log information, and even more importantly, the ability to analyze and visualize that data. And it kind of gives you the quote single pane of glass view of the overall health of your device fleet, right? So there's really 2 terms. There's device monitoring and there's fleet monitoring. They're kind of used interchangeably. Device monitoring, as its name implies, is typically for an individual device, whereas fleet monitoring is overall metrics about your entire device fleet. Things that are out of scope in terms of this particular talk, not going to be talking about remote access or control, although those kinds of things are all usually part of a system like this, but I'm really focusing on the fleet monitoring aspect. And then any use case dependent features are not going to be they're not part of this proof of concept. I'd love to beef it up. If anybody has ideas for how to make that proof of concept layer more interesting, I'll happily accept suggestions and pull requests on the GitHub link. So first thing you got to decide when you're monitoring your fleet is, what's important. Obviously, device health stuff is pretty important. Are the devices online or offline? What does that even mean? If a device hasn't checked in 5 minutes, does that mean it's offline? It really depends on the frequency of your polling intervals and things like that. Uptime, downtime, thermal, core service status. Obviously, resource utilization. We'll look at some examples here in a bit of CPU and memory utilization, device configuration. It's always important to know what versions are installed on all your devices, and more interesting things over the life of your product. When do things change? It was working, all of a sudden it stopped working. Was that related to an update? Was that related to some kind of environmental change? It's nice to be able to kind of start to be able to pull that information in and start to make some decisions based on it. Obviously, logs are very important to be able to troubleshoot things. And the trick with logs, of course, is that they're unstructured data. So it's not as simple as displaying a graph, for instance. And then some non-functional requirements to consider if you're looking at implementing a system like this. Is it open source? Is that important to you? Presumably for just about everyone on this call, that is important. Is it an on-prem solution, or is it something you could host yourself? Depends a lot on your use case. Medical devices, typically, a lot of times they have to have on-prem. A lot of the more the Internet of Things consumer devices typically are okay with hosted. What are the performance requirements for your system? You don't want a fleet monitoring daemon that puts significant load on the system just in and of itself. And then how well does it integrate with other services? Because no matter what you have displayed in that single pane of glass, there's always a case where you might want to get more information out and share that information with other tools that may not directly connect to your cloud services. So just talking about the general architecture, and I know you guys are all jealous of my mad graphic design skills here, but I think it kind of gets the idea. Typically in enterprise type deployments of fleet monitoring, you'll have multiple devices. They might be pulling metrics from some offboard devices, maybe SNMP or some cloud APIs. You do some local filtering on the device so that your clouds, you filter out the data that you don't care about. And then you might even do some filtering off the device. You pass it on to an upstream server that filters the data off the device. And then you might even have multiple outputs. So, for instance, in the case of Torizon, one of those outputs would be our Torizon server backend, but you could also have other services that you connect the devices to. And ideally, your fleet monitoring system would allow you that flexibility. So how does this change in the face of IoT? The biggest difference is the devices are generally much more homogeneous than they would be in an enterprise system. And the inputs typically come from just a few sources. Each of your IoT devices, normally they're not probably going to be pulling SNMP and getting lots of data about the environment they're in, although there's nothing stopping them from doing that. And also typically you're going to be fairly limited in the number of output streams as well. But those are just general characteristics. They're not obviously guaranteed to apply to any particular setup. So I'm just going to kind of skim through this slide real quick. So these are several of the options that we reviewed to include in our product. You can see some of the details here. Nagios Chi, they do have a nice demo server, and Yocto recipes exist, which is good. Elastic Stack is very common. In fact, that's part of what I'm using for the proof of concept. They do generally have a large on-device footprint, but there's this thing they call beats that is some mechanism to reduce that. I haven't really dug into it to understand it all that well. Datadog I thought was interesting because they're the only ones that explicitly mention IoT monitoring, but they're, as far as I can tell, completely closed source. And then a couple other options. There's Zabbix, which does have Yocto recipes, and Splunk, which is a very large system, and they can do quite a bit of stuff. You see the quote of how they define their own system. So these were all quickly eliminated from consideration, primarily due to their size and, in the case of Datadog and that kind of thing, the licensing, which didn't really fit within the Torizon architecture. So we were looking for something a bit smaller and definitely that was open source. So there's really two options that we considered and looked at. One is Telegraph InfluxDB. It's obviously an open source MIT licensed. It is written in Golang, which is nice because that does help eliminate the external dependencies. Although, there are issues with packaging, which were discussed yesterday. So, and it does take up 110 meg of flash is not nothing, especially, when some of our devices have as small as 512 meg. And there are Yocto recipes for it, so it's fairly easy to get up and running since our Torizon system is a Yocto-based system. And then the other one that we considered was fluentbit. It's fluentbit and fluentd. There's really two different implementations. Part of the Cloud Native Computing Foundation, which is a positive for us. You've got fluentd, which is the original. It's fairly large, has a lot of input and output plugins, takes up about 40 megs of flash. Unfortunately, it depends on Ruby gems, which does bring in a lot of dependencies and makes it a lot larger. And then the other one we considered was fluentbit, which is kind of a rewrite of the same protocols written in C to make it as portable and small as possible. It's got fewer input and output plugins and no external dependencies, which from our perspective is good. It only takes up a little bit of flash and a little bit of RAM. And of course, Yocto recipes exist for it. And obviously, we did choose, I think it was obvious from the way I was speaking about it, we did choose fluentbit. And the way we implemented it is, we've got the client agent in our base operating system. It's just running as a standard system daemon in the background. We have a custom output plugin that sends the data to our cloud over the existing transport in JSON format. And, out of the box, we support, generic metrics, CPU, memory loading, that kind of thing. But it is currently only time series data. We are trying to figure out how to support logs and unstructured data as part of this, but that's not currently implemented in our server infrastructure. But since as a user of Torizon, you have full access to the fluentbit configs and can do whatever you want with the fluentbit configs. If you have your own service infrastructure, you can add your own custom metrics, and if you want to use a second output stream, you can easily support unstructured data that way. And one of our plans is to eventually allow users to query data directly from Torizon. So, if you're a user and you want to do a little bit more visualization or filtering or something, and you don't want to or have the experience to stand up a server that with all the scaling requirements and that kind of thing, then you'll be able to actually pull the data directly from Torizon. And even in that case, if that's not sufficient, obviously, then you can go with a custom output plugin to do whatever you need. So let's move on to the proof of concept. So what we have is essentially just a custom distro and image. It's in the public Git repo that's on my GitHub. It adds fluentbit with a very basic configuration, and it will deliver data from there to Elasticsearch. And it can further then be visualized in Kibana. And I include a Docker Compose setup for the server side as well to easily launch Elasticsearch and Kibana. Right now, I'm running it all locally on my local area network here. I assume it can work in a more widely spread network, but I would be very careful because I have put zero thought into security of this particular proof of concept. So, like I say, it's in my GitHub, github.com, Drew Moseley, Meta Fleet Monitoring POC. So the image, pretty straightforward. Inherit core image, add fluentbit to it. Nothing magic here. It's intended to be very, very simple and very easy to use. And then just adding some configs. So I have a BB append to the fluentbit recipe that is going to add custom configs that you see here added in the do install append. And the only thing you'll have to do is make sure that you set fleet server URI in your build, in your local.conf, to make sure that you've got the IP address or fully qualified domain name of the server. And it's just forcing that value into the config files. And so this is the Docker Compose file that launches two services, Elasticsearch and Kibana, and they're set up to talk to each other. And in fact, I'm not sure I actually need to forward these 9200 and 9300 ports. I think Docker Compose would actually allow them to talk in the background, but I have not tested that yet. So right away, I think this can be made a little bit more secure. So fairly simple Docker Compose setup. Here's the instructions for doing a build with this. This, of course, assumes that you have a working Yocto build already for whatever machine you're using. Then you just add my layer into your configuration, set that fleet server URI, and then build the POC image recipe that's part of that layer. And then to launch the server, it's just a simple Docker Compose command that'll launch both of those services. So let's jump over and take a look at this thing running. I believe, okay, so I am sharing my whole window here. So here's my Elasticsearch instance. I've got a couple of devices running. One is a hardware device. It's an Appalus IMX8 running that image. I also have an emulated device running, just running QEMU here on my desktop. And I've set up a couple of visualizations, again, with my wonderful graphic design skills. We see CPU usage on the left, filtered out by IP address of the machine. And we see the memory used on the right, also filtered by IP address of the machine. So let's take a look. Where is here we go. So if I run the stress test on my Appalus IMX8, this refreshes every few seconds, and we should start seeing some interesting data come in. There we go. We're starting to see that the CPU usage has spiked, starting to see a little bit more memory usage. I guess the particular stress test that I'm using is more of a CPU stress test. I just copied and pasted off of a blog post for that. And so we can kill that off. And I had a couple other things I wanted to show here. So, and just so you can get an idea, so this is Elasticsearch and Kibana. This is Kibana connecting to Elasticsearch. So if we wanted to actually add a new visualization here, and you can do a lot more interesting things, but let's see, say we wanted to look at device temp. We go ahead and say, what is the device temperature? And I'm going to go ahead and sort it, break it down by host name. So it's obviously a very simple visualization, but kind of gives you an idea. You can see here where I ran that stress test. Obviously, the temperature of the device went up. My emulated device, being a QEMU device, obviously does not have any particular thermal measurements, so you're not actually seeing anything there. So these are the very basic visualizations. If you have a proper graphic artist and front end types that can do much more interesting things with it than I can, but that should give you an idea. So I also wanted to show just a little bit of the Torizon system. So this is our Torizon system, and so in here you can see we have multiple devices, and if I click through a specific device, which device is this? This is my Veridin. So if I go over to my Veridin, so we see that there's we've got the data coming in. This is all the same data that we were just looking at in fluentbit, only displayed a little bit more interestingly here in a well-designed user interface. And if I go ahead and start my stress test here, we should see some of the data starting to change, although I'm not sure off the top of my head what the frequency of polling is, so it might take a few minutes. But while that's going, let me jump over I mentioned there are two components to device monitoring. There's device monitoring and fleet monitoring. So what we've got for fleet monitoring in here, I've got a fleet of devices, all of my 3 devices. If I view details, so now we're seeing this is, this is all coming data coming from fluentbit, but it's kind of aggregated here and shown kind of device averages over the entire fleet. So that kind of gives you a picture of some of the things you can do. If we come back to our device, I believe it was this one. Yes. Let's look at the detail. Let's see if my stress testing is showing up in the pictures yet. Not really. So, but you can see, I guess the demo gods are not on my side for this part of it today. But if we, this is, like I say, this is the same data that we would see if we were the same data coming from fluentbit, just visualized in a different way. And with that, I want to just I'm going to change what I'm sharing here and just kind of go through some of the config of fluentbit to give you an idea of what the data, what the config looks like, and how you might change things. So from within my system, obviously we've got these files. Got the main config file. Most of it's commented out, but you see you can specify the obvious things. What port am I listening on, and that kind of thing. But really, the interesting stuff is what are these input? What are the plugins? What are the input devices? So let's take a look at plugins.conf. So in this case, I haven't added any. It's just using the standard stuff here from the existing directory. Parsers, this one I haven't worked with a whole lot, but so this is how data can be parsed and formatted for specific upstream recipients of the data. So JSON is obviously what we're using for most of our stuff, is we're just sending raw JSON. And if we take a look at, for instance, the CPU input, so this is where the meat of adding new metrics comes in. So in this case, we're obviously passing it out to Elasticsearch. We've got the IP address and port that it's going to, and we've got just some data, some naming information about it. So if we come, back over in Elasticsearch, that's where these devices, these metrics got their names. And in this case, we're just simply filtering and passing all the data back, adding a record of the host name so that we can figure out which host provides it. And I just put in another record called Awesome Tool, just to have yet another field in there. And similar, this is going to look very similar, is the memory stuff. So we're just matching anything in the memory output. Anything tagged memory is going to be matched by the regular expression here, and delivered up to Elasticsearch in the same way.